in the future is how I look at the future. Probably the past is more or less still the more or less false. Let me start with an analogy. When Carl Menger introduced the statistical metrics, he did it as a kind of help to understand quantum physics. This was his idea. And, well, actually, no physicists take care of the Menger ideas. Menger did not introduce T-norms and T-norms in the same way as we use it today. He never supposed associativity for T-norms and T-norms. And the idea, Menger idea of T-norms and T-norms was a very general idea. Of course, he introduced T-norms to establish a triangular property of the statistical metric spaces, but without associativity, it was really difficult to move triangular inequality to a polygonal inequality. And because of that, was that Schweitzer and Clark added associativity to the Menger's definition. Well, by a link between people working in statistical metric spaces and fuzzy logic, basically the case, T-norms and T-norms passed to the field of fuzzy logic. I think that today there is a new subject that could be in some way analogous to the idea of Menger. And this new field is the field of language. That is the obtention of mathematical models of language. I think that is a good field for mathematicians. I think that there are a lot of things to be done, mainly because language is studied by people in the brain, in their branch of humanities, and they don't have the hard sciences experimental methodology like is the case of neurobiologists, which they study the brain with signals, with a lot of technology. And I think that it could happen more or less the same that happened with Menger ideas. And I think that at least at the beginning, no linguist will take care of what we can do for language. I'm almost sure. I have an example. Some years ago, we published, actually with Claudio and others, a very interesting paper on antonyms. Antonymy is a very important feature of language, and no single linguist took care of this paper. And the paper goes farther than linguists work with antonyms, a lot farther than they can, but they are not interested. Of course, I am not making to you propaganda of mathematical models. You know that mathematical models are very, very, very important. Of course, as I said, language is largely a noun, at least from a hard science point of view. Today, brain is becoming to be known. Neurobiologists, they have a lot of information on brain. Up to, I don't know, 15, 20 years, that the brain was known in the external part. Any doctor can tell you what the brain is. The problem is not what the brain is, it's how it works. How it works. This is the great challenge for the 21st century. Of course, I think that for us, the knowledge of the working of the brain and of this manifestation of brain that is language, the end language is a manifestation of brain, is very important. For example, language is a great challenge for reaching computer systems of like people. What is that is saying that for more than 30 years. And see on that point, Ordinary reasoning is deductive in maybe 20%. No more. We never reason in a deductive way. Never know, but maybe at 20%. And what with the 80%, the rest of 80%? The rest of 80% can't be deductive. It's a kind of conjectural reason. It's because of that Lofi, when poses the problem of competing with wars, he says that the important are questions. You have an information. Oh, he always works with variables. But as an information, he tries to have a kind of aggregation of this information, and he's looking for a question. That is, an answer to a question. This is not a consequence, a logical consequence. This usually is a conjecture. Then, this kind of new ideas, for example, not to look at logic as the science of deduction, as logicians do indeed, and of course is important, but at logic as the science of reasoning. That was the old idea of logic. I say you this, the presence of symmetry in the way of obtaining the antonym. In the paper we sent in CwW, we show that the way of attaining all the antonyms of a given predicate is by using symmetries. Negation is a kind of symmetry with values. But to obtain antonyms, we need symmetries with the elements of the universal discourse. Symmetry is absolutely important in the understanding of the world, in physics, but it is also extremely important in the study of brain. Why? There are no mathematicians studying symmetry in language. We have a first example. There's the role symmetry plays in the obtention of antonymy. And believe me, symmetry is an absolutely important mathematical idea to understand the world and the brain. How mathematicians could work in this new lane, it seems to me a look at. I think that the two typical ways a mathematician works in the subjects. One is from the point of view of pure mathematics, and mathematicians will obtain results of a very general validity, applicable to competing with words or not, and this result will pass to the repository, to the archive of mathematics. Where are published the results? In mathematical journals, of course. There is the second lane, the lane of the work of mathematicians on particular problems in computing with words. For example, the problem of antonyms I told you. This is a problem that is linguistics, but important for competing with words. Why? Because, for example, to build up any linguistic variable, we need to have the predicate and the antonym. Absolutely clear. Of course, if you work only with a predicate in which the membership function is monotonic, increasing or decreasing, you don't need to know too much on symmetries. It's just one symmetry. But if the predicate is not always monotonic, for example, around 5, a triangle, you cannot use just one symmetry here. You need at least 2 or 3 symmetries there. And I think that there are interesting problems in computing words. And then, of course, mathematicians can obtain 2 kinds of results, or 2 kinds of researches. One that is just inspired by the problems. Most of my papers are just inspired. What I say, more or less, directed research. And other problems other papers can be problems solving a problem in computing with words. Then, the first kind of papers should be published in mathematical journals. And what about with the second lane? Well, if the problems are just inspired,